In this experiment, we had to investigate a sequence of reactions beginning with aluminum metal and ending with the potassium alum, and identify the reactions involved. We had to prepare a sample of potassium alum from ammonium and determine the percent. We had to synthesize an alum called potassium aluminum sulfate dodecahydrate, and we got this. By placing the appropriate ions in one container in an aqueous solution and then evaporated the water to form alum crystal. First, for the procedure, you need to obtain goggles and put them on and put on a pair of plastic gloves. And then accurately weigh out 0.5 grams of aluminum scrap. And you need to cut into small pieces about 1 to 2 millimeters thick and put the pieces onto a large 200 and 250 milliliter beaker. Then in the fume hood, you need to carefully add 25 milliliters of the 1.5 molar potassium hydroxide solution. And don't spatter the solution because it's very corrosive. Then heat the beaker gently over an open flame or hot plate. Continue heating for about 30 minutes until the aluminum is completely dissolved and no fizzing occurs. If the volume drops below half the original volume level, add distilled water.
Remove the beaker with tongs and use the glass rod to remove the small pieces of solid. Prepare filter paper, wet it, and place the funnel over the 250 milliliter beaker. Make sure the liquid is hot when you pour it into the funnel. Rinse the reaction with 2 portions of 3 milliliter deionized water. And to remove the insoluble solid, filter hot solution through the filter paper. Stir continuously when you add 9 molar H2SO4 until the pH is between 1 or 2. You might have to add 2 to 5 milliliters of the acid. Heat for another 10 minutes until the aluminum hydroxide dissolves. A clear solution should result. Remove from heat and cool in an ice bath for 20 minutes to form potassium crystals.
Collect the crystals by using a vacuum filtration with a Buechner funnel and a filter flask. After filtering the liquid, wash the crystals using several small 2 milliliter portions of the filtrate. To remove the excess water, use a dispose pipette and slowly add 10 milliliter of cold methanol. Place the filter paper and crystals into a watch glass to dry in your drawer until the next class. To calculate the alum product, we are taking the mass, which is 93.77, and that's the mass of the paper and the glass in the product, and subtracting it by 89.11, which is just the paper and the watch glass, and this gives us 4.66 grams. Next, we are going to determine the number of moles of aluminum that we began with. So we're going to take 0.48, which is how much we got to begin with, grams of aluminum, and 1 mole of aluminum is 26.98 grams. And this is going to give us 0.018 moles of aluminum. To get the number of moles of aluminum that we recovered, you take your 0.018 moles of aluminum, and then 2 moles of the alum is equal to 2 moles of aluminum. And this is just going to equal 1. So then when you multiply that out, you're going to get the same thing, which is good because you get the same number that you started with. To do the theoretical yield, we take our 0.48 grams of aluminum. 1 mole of aluminum is 26.98 grams. And then we take our molar ratio. 2 moles of alum is 2 moles of aluminum. And then we get 258.2 grams over 1 mole. And this gives us 5.3 grams of alum. To do the percent yield, you take the actual over the theoretical and multiply it by 100. So we're going to take 4.66 grams over 5.3 grams, because this is our theoretical, what we just calculated, times 100, and this gives us 88%.
Some things that may have caused errors was that our aluminum was not pure, for it came off a Coke can which had a thin layer of paint on the outside. We may have also lost some product transferring it from containers. We could also have miscalculations. We could have added too much or too little product, and we could have also let our solution come to a boil. In this lab, we started with aluminum metal and ended up with an alum product. The number of moles you start with should be the same amount you end up with at the end of the experiment in the product. We also determined the theoretical and percent yield.